Hi, my name is Nelson Gomez. If you remember, we were trying to do in our lab a lot of problems, and you did it together. But I found out that you had made some mistakes in the process, and want to make sure that all of you know how to do all of the things here. Here in this case, the problem is that we have two different units, right? And we are trying to add this up. This is a problem that you didn't have on your problems in the lab, but this is a problem that you need to understand as well. So you want to calculate something in kilometers, something in centimeters. You cannot add those up. You need to be on the same with the same units, right? Now, there are two ways of doing this. Both seem just as easy to me, but now this is what I'm gonna do. I'm gonna get them both to meters. So 1.61 kilometers, I'm gonna turn it into meters, and 50.01 centimeters, I'm gonna turn that also into meters. Now, here's one of the issues. 1.610 kilometers. This will be 1 kilometer, 1,000 meters. This will be 1,610 meters. And here is somewhere that you need to be aware of. That zero there creates a point that we don't know how many significant figures this new number has. Does it have 4 or only 3? Is this zero significant or not, right? To avoid that, one way of dealing with that is the following. In meters, you can say this is 1.61 times 10 to the 3 meters, right? If you remember that, this is what I did. We were in meters, right? And the decimal point is right there. By 10, by 10, by 10, you will have 1.61 by 10 to the 3, right? And in meters. Now, look what is happening now. Now you know that this has 4 significant figures. Now, the reality is that we don't really need that if you are keeping tabs while you're doing this exercise. So I'm going to continue doing the exercise so you will see what happens, okay? So you have 50.01 centimeters, and you know that 100 centimeters equals a meter, 1 meter, right? So you cancel centimeters, you divide by 100. Therefore, in meters, you will have 0.5001 meters. Okay. Now, this is pretty obvious. It's keeping its 4 significant figures. We don't have any problems with these zeros in the middle. Those zeros are significant. They are always significant. Now, let me go back and see if we can do this addition, right? Again, we can do it this way, and we will find a problem right now. If we try to add these two things up, because we have this multiplication here, you need to do the multiplication first, right? Now, I'm gonna just leave that in that side and write here the number in meters, and here the number in meters, and add this up. So this will be 1610.5001. Okay. this situation here, this is meters, right? This is not the right answer. This has too many significant figures. Now, how do we deal with significant figures when we have a case of addition and subtraction? It's not based on how many significant figures this has, 4, or how many does it have. It's not related to that. This is related only because we're adding or subtracting on which one of the numbers that we have has the lesser amount of decimal places. Really, the less amount of numbers in this direction, right? Usually decimal places. So here we don't have a decimal place, we don't have a decimal place, no decimal place, no decimal place. Therefore, we're being controlled not really by the amount of significant figures, but that here we need to do our rounding right there, just on the decimal point. Not necessarily, it doesn't have to be there. Yes, it is there because that's the way it works out. Okay. Now, then I need to get this here and round this number. How do I round this? Okay. Because I have a 5 here, that might make you think I need to go to the closer even number. But that is not just exactly a 5. We are rounding more than exactly 5. This is 5001. And because we have just a little bit more than 5, then we round up in this case. So this will be 1611 meters, right? The right answer in this case will be 1611 meters. Look, this is important. If our numbers were something like this, okay? I'm gonna erase some things over here. If our numbers were something like this, right? This is not there, okay? This will not be there, okay? Now, when we round this up, we still need to do it here because it depends on the decimal places on the one that is worse, right? It will be 161, but the last digit is gonna be a 0 because 0 is the closest even number that you have there. Because this is a perfect 5. 5 with a 0 after, or 5 with nothing else after. That's a perfect 5. Perfect 5, when you round that up, will go to the closest even number. Okay? Now, if this was a little bit different as well here, and let's say that we have a extra 0 over here. You see this? An extra 0. Then this will be a 0 over here, right? And we wouldn't have this last decimal place, but when we are about to do our rounding, it will be to that level. So the answer will be 1610.5 meters. Now we are keeping the significant figures. But remember, we're really keeping the one that has the less amount of decimal places. That is the one that is controlling us in this case. Now let's do another case. Let's say that instead of being like this, we don't have this last 0, okay? We don't have it, okay? So now, this 0 is not significant. That might be a problem for us, okay? I'm gonna do the relatively easy version now that we have I wrote everything there. But because this 0 is not significant, you need to round right there. That's what you need to round. And if you round that right there, this will be 161 and a 0 that is not significant. Okay? A 0 that is not significant meters. Now, again, it's kind of weird, right? We're adding something, we have the same number in the end. But the issue here is that we cannot really know what will change because that last number is not significant. Let me do it in another way. This same problem in another way. So in this problem, we're considering 50 centimeters here, 1.61 kilometers. If this is the case, instead of doing what I was doing before, going to meters, I probably stay in kilometers, okay? So I will have 1.61 kilometers, but the 50 centimeters, I will do, okay, 100 centimeters is 1 meter, and 1,000 meters are equal to 1 kilometer. So meter, centimeter, centimeter, we will have that in kilometers. That will in turn be let me check it. That will be 50 will be 0.00050. Again, I have to keep my significant figures here. I had two. I'm keeping my two significant figures over here. But now this is on kilometers, okay? But I'm keeping my significant figures. With this number now, I can go over here and say 0.00050 kilometers. And look, if I do this addition here, I have to stay right there, right? Because that's my right there, no. Right here, I'm sorry. Right here, I have to stay right there because I only have two decimal places in that case. If I round that up, it will be 1.61 kilometers. You follow? That's exactly the same answer we got before. Now, why is this working like this? Very easy. If you are measuring in kilometers and this way, and this is the way you are measuring, really, this measurement can be, let me just erase everything there. This measurement that we're doing here, this can be either 1.649 kilometers, or it can be as well, 64 now, 6149, okay? 1.6149, and it can also just as well be 1.6051. I'm just trying to show it clearly that that the 5 there, I want to deal with the 5 right now. But really, it can be anywhere within the 1.6051 or 1.6149. We have all that space that we don't know really what is the number here. If you go here and do something like this, you are saying that you know that these are zeros. And we don't know that. We don't know that. It can be any number between those two numbers right there. So because we don't know that, that is the way significant figures work. Okay? Because we don't know what is happening after that number, we don't know what is happening with this addition there. Now, if those numbers were big enough to show us that it's going to change, of course, we will change it, okay? But that is not the case here.